Hello everyone, this is the video answer key for the practice for triangle coordinate proofs. All right, number one, we have triangle ABC, which has those vertices, and we want to prove that ABC is a scalene triangle. And now let's recall that a scalene triangle has all three sides that are different from each other in terms of length. So that means we're going to need to use the distance formula 3 times. Here we go. So if just like in the notes actually, if you want to go ahead and graph this triangle on the grid, or if you just need to see like which sides you need to do, you can just draw a little triangle, rough draft off to the side, and you can see which sides you have done. So the first side that we need to do, I'll just start with AB. Okay, here we go. So side, I want to do the distance of AB. Let's just remind ourselves what the distance formula is, x2 minus x1 quantity squared. And this is y2 minus y1 also quantity squared. And that is all underneath a radical. All right, plug in time. Here we go. For AB, my x2 is this -5, and I'm subtracting a -8. -5, subtract. Again, I'm going to put that -8 in parentheses just so that I can see that I am subtracting a negative. And then my y2's are 5, subtract 1. All underneath the radical. What does this give me? -5 minus -8, that turns into -5 plus 8, which is +3. +3 squared is 9. Adding to that, 5 minus 1 is 4. 4 squared is 16. So this gives 9 and 16 is 25, radical 25, which is of course 5. All right, my next distance that I have to do, I am going to do, I've already done AB, so let's just do BC, go around the acronym. So I got BC this time. So BC, and if you notice, I have not labeled my X1s and Y1s up here just because it's going to get too cluttered up there for my liking. If you have different colors, yes, I could have written it in red and then blue, and then if I needed for the third one, I can do like green. So if you have your own colors and it works for you, it's not going to be too cluttered for you, go right on ahead and label it with the different colors. All right, so the distance of BC, I'm just going to plug it in because I already have my formula up here that I can reference if I need to. So BC, my x2 is 2, and I'm subtracting a -5. Oh, that's +2. Looks like a Z. 2 minus -5. Again, that -5 is in parentheses, so I can see that I am subtracting a negative. And then I have my y2, which is 3, and I'm subtracting 5. All underneath the radical. So I got 2 minus a -5, which turns into 2 plus 5, which is 7. 7 squared is 49. Then I got 3 minus 5, which is -2. -2 squared is 4. 49 plus 4 is 53. Radical 53. So good. My two lengths so far are different from each other. That's what we want. All right. My third length I need to do, this is going to be the side. I've already done AB and then BC. All I got left is AC. So AC. Again, I'm just going to plug in. So we got A, and C here. So I got to be careful. My X2 is this 2 right here, and I'm subtracting a -8. 2 subtract -8. Quantity squared. Now what do I have? My y2 is this 3, and I'm subtracting 1. 3 minus 1 squared. All underneath the radical. We'll just move this guy up. There we go. I got 2 minus a negative 8, which turns into 2 plus 8, which is 10. 10 squared is 100. So already I can tell this is going to be different because I'm adding, and I'm already over radical 53. Let's just check it out. 3 minus 1 is 2, excuse me. 2 squared is 4. So this gives me radical 104. Perfect. So I have 3 different lengths. I got a 5, radical 53, and radical 104. I have a scalene triangle. So now I just need to formulate my arguments, aka write my sentences. So triangle ABC has 3 sides that are not congruent. Therefore, triangle ABC is isosceles. Oops, there's an S before that, see? There we go. That's it. Number 2. Here we go. Now we have triangle RST this time, and we want to know, is this a right triangle? So for a right triangle, we know that there is going to be perpendicular lines at some point. We don't know where that is yet, but we know there is a perpendicular, there are perpendicular lines somewhere in here. So we need to test the slopes of all three sides, and then we're going to see, well, which one of those slopes have a negative reciprocal slope to it, and that's when we'll prove that there exists a right triangle. 2 consecutive sides have a negative reciprocal slope with each other. Here we go. So again, I'm not going to label my x1, y1s just because it's going to be too convoluted since I'm doing 3 different sides potentially. So I got to do the slope, which is small m. Make sure that thing is small. Again, if you wanted to draw like a cursive m, but be my guest if you know how to write cursive. I'm just going to leave it as a small printed m. So the slope I'm going to do of rs. So let's just remind ourselves it's y2 minus y1 over x2 minus x1. So rs, my y2 is this 4, and I'm subtracting 1, and I see that that's going to be the same thing for the bottom as well. So 4 minus 1 on top, 4 minus 1 on the bottom, which turns out to be 3 over 3, which equals a slope of 1. Okay? So now I got to do the slope of S and T. ST. I'm just gonna plug in right now, yeah, because I already wrote my formula. If I need to refer to it, it's right up there. So S and T, my Y2 is 2, and I'm subtracting 4. And then I have my X2, which is 6, and I'm also subtracting 4. So 2 minus 4 is negative 2. Oops, hey now. There we go. 2 minus 4 is negative 2. 6 minus 4 is 2. So that gives me a negative 1 slope. So here is my right angle right here. I can stop right now because I have shown that there is negative reciprocal slopes, or that there are perpendicular lines, and that means that there exists a right angle. So this is a right triangle. So now I can say that triangle RST has a right angle, therefore triangle RST is a right triangle. Boom, done. All right. Well, that's it for this practice. I hope this helped. As always, be safe and be healthy, everybody. I'll see you next time. Bye.